Hey there. We're going to be talking about equations of lines now. And this is actually just one particular form of an equation of a line that I want to talk about. It's called the point-slope form. The reason why they call it a point-slope form is because all you need in order to find the equation of the line is one point on that line and the slope of that line. Let's just try it real quick. If I was given that the slope, typically we use the lowercase m for slope. If our slope was, say, 1/2, and a point on our line was 2, 4. Given these two pieces of information, the point and the slope, we could build the equation of the line that passes through this point with this slope. And it's as easy as pi. Y minus y1 equals m times x minus x1. Now, it may seem a little confusing. We have all these y's and x's floating around, but what we like to do is just kind of utilize a subscript here for y1 and x1. Those the x1 and the y1, those are going to be the x and y coordinates from the point that we're given. So we know that this point is already on the line that we're trying to build the equation of, right? And m here is the same lowercase m that I'm using for slope. You'll notice that that's very typical, conventional in mathematics. So what we're saying is that if we know that the equation of the line is this, and we're given this, all we have to do is plug it in. Plug it in, as they say. Hopefully that's not copyright infringement. We're not going to sell these videos anyways, right? Who's making money here? Are you? It is. Y minus y1 is 4. That's the y coordinate of the point that we're given. Equals m is 1/2 times x minus x1 is 2. That's the x coordinate of the point we're given. That is an equation of a line. The equation of a line is just that we have now infinitely many x, y coordinates that will fit on this line, that will actually lie on this line. Now, do you want to see this line as maybe intercept form, slope-intercept form, where we have y equals 1/2 x minus 1 plus 4? As it turns out, these are the exact same line. The thing is, this line doesn't necessarily tell you that 2, 4 lies on it unless you check. You could plug in the x coordinate here and the y coordinate here, and you would find that it makes the equation true. And that's precisely what happens here. If we plug in 2, 4, the coordinates in the x and y here, we will get a true statement. Sometimes we're required to find the equation of a line, but we don't know what the slope of the line is yet. Maybe they're going to give us some information where we can kind of extract the slope of the line based on that, and then use what we know about the equation of a line using point-slope form to build the equation ourselves. Now, we could, say, take 2 points in space. Let's say 3, 4 and 2, 2. Now, we know these points exist on the Cartesian plane, right? We could graph them real quick and say 1, 2, 3, 4, 1, 2, 3, 4, 2, 2 is right here, and 3, 4, 1, 2, 3, 1, 2, 3, 4 is right here. And, well, there's 2 points in space. You may have heard something along the lines, We're talking about lines, I like that. You may have heard something along the lines of, all you need to define a line is 2 points. Like, all you need, that's it. You have 2 points in space, I can tell you the equation of the line that's between them. To find the slope between these 2 points, all we have to do is find out how much the y-coordinate changed and how much the x-coordinates changed between the 2 points, and we find the ratio of the two. Now, really, all that means is, well, if I'm moving away from this point and I want to walk along the line that gets me to this point, I could think of it as moving along the grid of this plane, where I move up 2 and I move over 1. Now, the slope of the line, m, is going to be how much we change the y divided by how much we change the x. You may be asking yourself, why did I choose 4 instead of, why did I choose 4 first, right? Why did I do that one first? Well, I took the y from this and subtracted the y from this. And then I took the x from this one and subtracted the x from this one. The thing is, it doesn't matter which order you do it in, but you have to stay consistent. So if I chose the y value of the second point and then subtracted the y value of the first point, I have to do the same with the x value. The x value has to start from the second and then subtract the first. Now we could just simplify this into that. So the slope of the line between these 2 points is 2. The point that we decided to choose was 3, 4. Now, using point-slope form of the equation of this line, I'm going to be able to build the equation. Y minus the y-coordinate of the point we decided equals m, the slope, times x minus the x-coordinate. And that right there is the equation to the line between these 2 points. This equation, if you were to find all of the xy pairs that make this equation true, those are precisely all of the points that fall on this line, right? It's this line that we've just created. And every point on this line, there's infinitely many points. All of those points have an xy coordinate, say x star comma y star. If we were to plug in x star y star into our equation here for x and y, we will get a true statement. Notice that if we plug in 3 comma 4, we'll get 0 equals 0. Well, 0 does equal 0, so that's a good thing. What if we plugged in 2 comma 2? Didn't we say that 2 comma 2 lies on this line? Well, if it does, it will indeed make this a true statement. Why don't we see what happens? We have 2 minus 4, that's the y-coordinate from here, equals 2 times 2, the x-coordinate, minus 3. 2 minus 4 is negative 2. And this is 2 times 2 minus 3 is negative 1. Well, 2 times negative 1 does indeed equal negative 2. The fact that we got a true statement here means that the point 2, 2 lies on this line. That's a nice way to be able to check our answer, right? So, utilizing what we know about finding the slope between 2 points, we can find the slope, and we just choose any 2 of those points, either one. And now we can just fill in the blanks, right? y minus y1 equals m times x minus x1, right? I'm going to write it down again right here. You might have to write it down a few times to remember it, but once you've got it, it's locked in there. And you could build the equation of a line anytime you want. And guess what? When you get to calculus, this m right here becomes very important. And we can use the slope of a line to talk about a lot of things. And sometimes we like to be able to know what the equation of the line with that slope is. This is going to help you out quite a bit. And once you get to calculus, you're going to be like, man, that guy Colin on that video in that one math class I took was really spot on. Trust me, I know you can do it. You may be given the equation of a line and then asked to extract information from it. Or you may want to be able to do it for yourself in certain situations, right? Now, what we could start with is maybe given the equation of a line, what kind of information can I get from this, right? Well, first off, what's the slope of the line? Secondly, are there some points that satisfy this line that I could just maybe by inspection find them? Why don't you pause the video real quick and try to answer these two questions? All right. So the slope, relatively easy because, well, we know that this is point slope form. And I'll tell you what, that's the slope of the line, right? Nice. Are there any points that satisfy this line? Well, at least I hope there's at least one, right? But it turns out there's infinitely many. But I can find one really easily. I'll show you. What makes the left side of this equation 0? A point whose y-coordinate is 2. Can we make the right side 0? Well, a point with the x-coordinate 5 will cause this right side to be 0. So the point 5, 2 is definitely on this line. Now, given a point and a slope, I could do a whole lot, right? I can actually find every other point on the line that I ever wanted to find. How do I do that? Well, let's graph 1, 2, 3, 4, 5. 1, 2, 3, 4. Here's 5, 2. And I want to find just one more point that's on this line right here. Well, I know that the line has a slope of 1/4. So if I want to just show what this line is graphically, I could take this point and add another point that happens to be 1 unit down and 4 units over. 1 unit down and 1, 2, 4 units over. And check it out. That's a slope of positive 1/4. And I can keep doing that forever. There's a nice line with a positive slope of 1/4. Remember, positive slope looks like this, right? It looks like it's uphill going from left to right. A negative slope would give you something that goes downhill from left to right, right? Well, what if I wanted to find out what this y-intercept is? That's another piece of information we could find just based on this equation of the line, right? One of the ways to do that is, well, set x equal to 0. Find out what y happens to be, right? If I say, I know there's a point on this line where x is 0. Well, what's the y value if x is 0? Why don't we just plug it in? If x is 0, we get y minus 2 equals 1/4 times 0 minus 5. Okay. Well, this is really y minus 2 equals 1/4 times negative 5. So that is y equals 1/4 times negative 5 is negative 5/4. And that's plus 2. 2 is 8/4, so this is really negative 5/4 plus 8/4 is 3/4. So when x is 0, y is 3/4. Hey, I found the y-intercept. What's some more information that we can get from that? Well, I know that I could put the equation of this line in y-intercept form now, right? Because I know what the y-intercept is. I know what the slope is. And that's actually all you need for y-intercept form, right? We have y equals mx plus b. Well, b is 3/4. M is 1/4. Wow. Isn't there so much information we can pull just from a single equation of a line? Can you come up with 3 more points that fall on this line? One little question, maybe a big question, is, does this line cross the x-axis? An even more interesting question might be, do all lines cross the x-axis? If not, what properties of the line would have to be true in order for it to not cross the x-axis? What lines have slopes that allow you to cross through the x-axis? These are all interesting questions, and conceptually, I believe you'll understand them as you travel through this math course. I was giving you some time to think about it. You could also always pause this to think about any of the questions that I ask as well. Did you find 3 more points that are on this line? Maybe we could just label these. You found 3 or 4 points there. Now, does this line cross the x-axis? This one is the x-axis here. Well, I'll tell you what. It looks like it is going to over here, but I can't be sure. So, is there a way that I could tell if it does cross the x-axis? Well, if it did, then there is exactly one point where the y value is 0. Huh. Well, if the y value is 0, that means I just have to find the x value. And I already know the equation of the line in terms of x and y. So I could just plug in 0 for y and solve for x. That x value will give me where this line crosses the x-axis. So it not only can I tell you that it does cross the x-axis, but I can tell you exactly where it does. And let's do that right now. This is just 0 minus 2 equals 1/4 times x minus 5. What I've done is take the equation of the line and plugged in 0 for y. Negative 2 plus 5/4 is going to be negative 3/4 equals 1/4 x. So the point -3, 0 also lies on this line, and it happens to be the point where this line crosses the x-axis. So again, we kind of revisit these questions that I asked. Does a line always have to cross through the x-axis? What do you think? It turns out, no, it doesn't. But most of the time it does. What do you think it could be that's causing the line to go through the x-axis? I'll give you a hint. It has a lot to do with our buddy slope here. Think of the one case where this line will not go through the x-axis. Here's a line. It is parallel to the x-axis, right? This line right here, its equation is y equals 3. This line will never cross through the x-axis. One way to see that is that it's parallel to the x-axis, so two parallel lines will never intersect. That's the parallel postulate from Euclid. Now, we don't want to think of it that way. Why don't we say, well, just the equation, right? Y equals 3. What did we do to find the x-intercept earlier? We set y equal to 0 and then solved for x. If I set y equal to 0 right here, I get 0 equals 3. Well, 0 does not equal 3. And that's my only choice here, right? Can you think of any other time where we have a line that doesn't cross through the x-axis? I don't think you can. But you may have thought now with horizontal lines, what about vertical lines, right? What about the line x equals 1? As it turns out, vertical lines have undefined slope. Although this does cross through the x-axis, it will never have a y-intercept. Now, I hope you enjoyed this video. I went off on a little bit of a tangent at the end here just to kind of see all the different information we can pull from this one equation. And the thing is that you'll begin to notice that the further you get into this mathematics stuff, the more of it starts to relate to one another, right? There's a lot of patterns that you wind up seeing that allow you to break problems down into smaller, more manageable pieces that we can tie in at the end. So a lot of this stuff that I'm talking about is all just tools that you can pull out of your tool belt and say, oh, you know what? I remember that. I could say, instead of starting with the equation, I could start with a line and slope. Or I could start with an equation, get the line and the slope, and use that information for something else, right? Now, I know some of this can get very complicated, but I know that you can do it. So get back there, get your homework done. I'll see you in class.